And we're live. Welcome to 8:30 Prep. I'm Phil McCaffrey, and this is a production of 3 Hour Prep, my tutoring company. And I want to give a huge shout out to Gavin and Abby, who emailed me that they'd be on, and I see that they have already made a comment. So Gavin, if you can see the screen, first off, always say hello to Damien, my producer.
What's up?
And his humble assistant, Teo Hadfield.
Hello.
So we got 2 producers. We're going to be doing this throughout the coronavirus lockdown. I'm going to be Monday through Thursday night, 8:30 Prep, just coming up with SAT and ACT questions to play with. Today I'm going to finish my ACT formula sheet, but I got a question from Gavin, and that is off of the C. Is this the CO5? Is that what test this is? This is off the December test. So let me get a pen. And this is from December of, Ben Esser, love you. Ben gets a bonus point. All right, if you're from my North Catholic class, you get a bonus point for making a chat. So this is December of 2019, and let's jump right into it. The question reads, the digit, you have to know what a digit is, in the ones place, which is really weird they said the ones place. That's the first use of it I've seen. They used to say unit. The SAT used to love the word units place. Of 2 raised to the 88th power is 6. What digit is in the 1 place of 2 to the 90th? Well, this is one you can't use your calculator because your calculator doesn't go up to 2 to the 90th. The numbers are too high. But let's take a look at the powers of 2. 2 to the 1 is 2. 2 to the 2 is 4. 2 to the 3 is 8. 2 to the 4 is 16. 2 to the 5 is 32. 2 to the 6 is 64. 2 to the 7th is 128. And 2 to the 8th is 256. The pattern here, Gavin, is 2, 4, 8, 6. 2, 4, 8, 6. So if 2 to the 88 is in the 4th column, that means 2 to the 89 ends in 2, and 2 to the 90 ends in 4. The correct answer is C. It's a repeating pattern. This is actually a sequence problem that the old SAT used to love. And I'm really surprised the ACT has put this on. It's also a remainder problem because 4 divided into 90 goes 88 times with a remainder of 2. So this is 1, 2, 3, 4. So a remainder of 2 puts us in the 4th place. Thanks for the question. Gavin, you get Ben's on there. What's up? So excellent. All right, we're going to talk about geometry, trigonometry, and statistics today. So the first thing is what's covered on the ACT in geometry. This is all of the things that they cover. And just like you, I hated geometry class in high school. My teacher was terrible, and then I was a geometry teacher for 1 year, and even though I thought I was a pretty good teacher, I was terrible and the class was terrible, and there's not much fun about geometry whatsoever unless you do some really, really good projects. What does the ACT cover? They cover lines and angles. Triangles are huge. It's on there 100% of the time. Quadrilaterals, squares, rectangles, and trapezoids are the 3 big ones. Polygons, which a triangle and a quadrilateral is a polygon, but this is also a pentagon and hexagon and bigger than that. Circles, radius, diameter, area, perimeter, circumference. The perimeter of a circle is called circumference. And then I put in arcs and sectors as a separate part of circles because it's a unique problem. It's a proportion. I'll show you that. And then solids, boxes, balls, and cans. Let's jump right into this and go into lines and angles. What's the primary thing they test? Well, if a line is separated by an angle, say this is 40 degrees, an angle of 40 degrees has a supplementary angle. I have to send that off as a shout out to my boy Nate. is 180 minus 40. So this is 140 degrees. Lines have 180 degrees. The thing they love to test is parallel lines. Ooh, look at that nice whiteboard. I love a smartboard. I love this software. So if we put angle X here, there is something that they always test, and that is vertical angles are equal, and then these angles are equal. If we put this as angle Y, its vertical is Y here, and its vertical is Y here. So there are parallel lines. Let's call this L and M, and make sure we write L is parallel to M. They use both the parallel symbol, the two lines, as well as the word parallel. And these are supplementary, so X plus Y is equal to 180 degrees. They'll number them and they'll say something like 1, 2, 3, 4, which ones are equal to X, or which ones are supplementary to X, or which ones add up to 180. But these are the two primary things they test about lines and angles. When we get into quadrilaterals, the one thing that you'll notice is that a trapezoid is two parallel lines cut with a transversal. So they like to ask that very much. Triangles. Triangles is a huge lesson. The most important thing to know about a triangle is, of course, 180 degrees. This comes up many, many, many times. What are the triangles they test? The first one is our favorite, the equilateral, equiangular. Equilateral, equiangular. In polygons, that's also called regular. Regular means that the sides are equal and the angles are equal. In this triangle, it's 60, 60, 60. They also test isosceles, which means that two sides and two angles are equal. IOSCELES. The word isosceles is also fair game. An equilateral triangle is an isosceles triangle because it does have two equal sides. So the definition of an isosceles triangle is at least two equal sides.
It's a nice little face you drew there.
Nice little face. Where did I draw? Is this a face?
Number 2.
Number 2 is a face. It looks like a face. There's also an isosceles trapezoid, and that's come up one time. All right, let's go back to purple. Now let's switch to blue. All right, everybody's favorite, the right triangle. Everybody assumes that a triangle is equilateral or isosceles or a right triangle. That's not the case, but these are the big three. And of course, this is the Pythagorean theorem. A squared plus B squared equals C squared. Almost everything else they test about triangles are right triangles, and I'm going to add a page and do special right triangles. But the one thing to know, particularly about a right triangle, is that the hypotenuse is the side opposite of the right triangle. So the hypotenuse is definitely fair game on the test. And any triangle, A plus B must be greater than C. Whatever sides of the triangle, the other two sides have to be greater. If you look at it, these two sides have to be greater than this side, or they don't match. It's not a triangle. So two sides of a triangle added together is equal to the third side. And of course, the sum of the sides is the perimeter. Let's add a page and do the Pythagorean triplets. So Pythagoras was a religious leader in ancient Greece. He made a religion out of studying triangles, and he discovered the Pythagorean theorem. And the most important triangle is the 3, 4, 5. Similar triangles, this of course is a right triangle. Similar triangles to the Pythagorean triplet are 3, 4, 5, and then multiples of it, like 6, 8, 10. That's times 2. Times 3 would be 9, 12, 15. Times 4 would be 12, 16, 20. These come up all the time. Be on the lookout for them. What other Pythagorean triplets are there? There is the 5, 12, 13. The 7, 24, 25. And the 8, 15, 17. It's not that important that you memorize these. I would absolutely memorize the 3, 4, 5 and the 5, 12, 13. But if you want a really high score, if you're shooting for over a 30, definitely know your Pythagorean triplets. The interesting thing about a Pythagorean triplet is that there are infinitely many of them, because the short side of a Pythagorean triplet is a prime number. So all prime numbers form triangles that are integer sides. And interestingly enough, the sum of the other two sides, like 7, the 7, 24, 25, 7 squared equals 49. And the sum of the other two sides is 49. 5 squared is 25. And 12 plus 13 is 25. 3 squared is 9. And of course, 4 plus 5 is 9. Little bit of tidbit, a little bit of math trivia, not so important. Most comments ever. I've sent out a bunch of emails and I've got all of my students in there, so let me write a comment back in there. It was like, hey, North Catholic Trojans. You guys are all getting points. I'll be saving these bad boys. All right, what's up next? Quadrilateral. What's our big and famous quadrilateral? The square. What else do we also like to have is a rectangle. The thing about a square is that we have perimeter and area. The perimeter of a square is the side times 4. I didn't give myself enough room. Let's move area way over here. Oops. So this is the side times 4, 4 side. And the area is side squared. That's where the exponent 2 comes from. It is the area of a square. What other things they have are rectangles. This will be width and this will be length. The area of a rectangle is equal to length times width. If they give you the perimeter of a quadrilateral or a rectangle and they say the maximum area, the max area of a quadrilateral is a square. Let's prove it. Let's say the maximum, let's say the perimeter of this is going to be 8 times 4, 32. So if the perimeter is 32, then my square is going to be 8 times 8. 8 plus 8 plus 8 plus 8 plus 8 is 32. The area is 64. I can take this and make it 1 foot wide and 64 feet in perimeter. So what would I do is take 64, subtract 2, and I would get 62, and this area would then be 31. Same perimeter, completely different area. So the biggest area is a square. Let's add another quadrilateral. What comes up is a trapezoid. And the thing about a trapezoid that I already talked about is that the sides here, if I call this x and this y, is x plus y is equal to 180 degrees. Because the top and the bottom are called the bases. We'll call this base 1 and base 2. And they are parallel. What is the area of a trapezoid? You need to know this formula. The distance between the bases forming a right angle, like a triangle, the height of a triangle, is base 1 plus base 2 divided by 2, or the average of the two bases multiplied by the height. That's the area of a trapezoid. Definitely worth knowing. Ben, big SAT fan. Most places were closed. I think the next test is in June. Absolutely. Let's hope the next test is in June. Let's hope we're all not stuck inside until June. All right, what's up next after quadrilateral? Polygons. I wanted to do regular polygons here. And of course, I already talked about a regular polygon, a regular triangle, which is 60 degrees, 60, and 60. So the total is 180. The sum of the three angles is 180. The individual equal angular is 180 divided by 3, or 60. A regular quadrilateral is a square, and that's 360 degrees, or each angle is 90. A regular pentagon, worth memorizing, is 540, and 540 divided by 5 is 108. Yeah, I got my test moved back. And now we've got this is a pentagon, and here's a hexagon. It's 720 degrees, and each individual angle is 120 degrees. There's a formula for this, and that is the number of sides minus 2 times 180 gives us the sum of the angles. If we divide this by n, we get the individual angle. The one thing that they like to do is split up a 6-sided regular polygon into 6 equilateral triangles. Worth noting that I skipped on triangles is that a square split in half forms a 45, 45, 90 triangle. I skipped these, I'm coming back to it. 45, 45, 90. If the two sides are equal because it's an equilateral, the hypotenuse is side times the square root of 2. The other special right triangle is an equilateral triangle split in half, forming a 30, 60, 90. And a 30, 60, 90 has unique relationships, and that the short leg is x, the hypotenuse is twice the short leg, and the long leg is x times the square root of 3. So notice square root of 2, square root of 3. These are irrational numbers, and our next great irrational number comes with the circle. And the great irrational number associated with the circle is pi. So let's use our board and toss in a circle. And what are the parts of the circle that we want to know? Well, absolutely, everybody knows that a circle cut in half forms a diameter. And the diameter cut in half forms a radius. So 2 radiuses equal 1 diameter. The circumference of a circle is equal to 2 pi r, or pi times the diameter. Pi is equal to the ratio of the circumference to the diameter. That's worth restating. The area is pi r squared. The one thing I want to point out about the ACT and the SAT is that notice how close circumference 2 pi r is to area pi r squared. They have the exact same symbols. So on a harder problem, they'll ask for the circumference, but they'll give the area. So if the circumference, if the radius is equal to 6, 2 pi r gives us a circumference of 2 times 6, or 12 pi. An area would be pi r squared, or 36 pi. They don't put in the units. In a circumference, it would be centimeters. In an area, it would be centimeters squared. They leave this in the problem. Make sure you know your formulas. The ACT does not have a formula sheet. The SAT does. I'd like to, yes, you definitely should memorize the formula for that. Nice notes. Thanks, you guys, for all the comments. But definitely memorize a circle. And I'll be posting this PDF in the comments of the YouTube video. Arcs and sectors. Let's draw another circle. A little too close. Let's move my... Oh, let's not move that one. Let's move this one. What is an arc? An arc is when I take a piece of a circle. So the sector is the slice of it, like a slice of a pizza. And the arc is the distance between the 2 points. So this is the origin, and the arc is A to B. So the angle formed by the sector is called theta. Theta divided by 360 forms a ratio that is the same as the arc length divided by the circumference, or 2 pi r. It's also equal to the sector area. Let's fill in the area here with some red markings. There is no symbol in math for a sector area, so we're just going to put a piece of pi there, pi r squared. Where does the ACT like to test this question? They love it in pi graphs. So they will give a pi graph and they will say the angle is off. Students miss this one all the time. And what this is the part divided by the whole. That's the fraction or ratio. A part of a whole is equal to it. So whatever the sum of the circle graph is and the sector that they're looking at is a part divided by a whole. And I feel a sneeze coming on. Let's finish up here. Solids. The solids that they like are spheres, right cylinders, and rectangular prisms, or boxes. So I call this boxes, balls, and cans. Length times width times height. Pi r squared h. And 4/3 pi r cubed. I have never seen it where you've had to memorize a sphere. This would be a sphere if I drew it as a three-dimensional object. I've never seen them put a sphere or a cone or a pyramid on where you've had to memorize it. But definitely the height and radius of a right cylinder and the volume. One question that they particularly like is a tank filled with water, and then they submerge something to figure out its area. When they submerge something, the only thing that changes is this height. The length and the width stays the same. So the volume of the thing they submerge into the tank is the length times the width times the change in height. Trigonometry, SOHCAHTOA, right triangle trigonometry. Let me get a right triangle out here. And here's my right triangle. Even though it's an isosceles triangle, I'm going to call it a 3, 4, 5. And I'm going to make this angle theta. SOHCAHTOA is sine, cosine, and tangent. The sine of angle theta is equal to its opposite side, 3, divided by the hypotenuse, 5. The cosine of theta is equal to the adjacent side. We'll call this the adjacent. We'll call this the opposite, and this the hypotenuse. And this is equal to 4 over 5. And the tangent of theta is equal to the opposite over the adjacent, TOA. So the opposite is 3, the adjacent is 4. Interestingly enough, this angle up here is 90 minus theta because this is a right triangle. So I'm going to sneeze, I'm sorry. The cosine of 90 minus theta is equal to the sine of theta. Cosine of 90 minus theta would be the adjacent 3 over the hypotenuse 5. That's fair game on there. The other questions that they ask on trigonometry there are 4 trigonometry questions. So there's always 4 trig questions. 2 of them are sine, cosine, and tangent, or our famous SOHCAHTOA. Of the other 2 questions, they're made up of the unit circle, trig functions, where the function of x is equal to the sine of x, and 3, the law of sine and cosines. I have a playlist on my YouTube channel if you'd like to learn the trigonometry. So 4 trig questions, 2 SOHCAHTOA, 2 out of the 3 other things they test. If you're in pre-calculus, you can definitely do these. If you're not, you can learn them and get a high score. Thank you for the review. You're welcome. Should we memorize the formula n minus 2 times 180? Christina, absolutely. Definitely memorize that formula. Now we're getting into statistics and probability, and we're going to wrap up soon. That's pretty good because we're hitting 20 minutes. What is on the test 100% of the time? Mean, median, and mode. The mean is the average, and I've never met a student that didn't know the average divided by the sum of the set divided by the number of the set equals the average. But students miss this problem the most. The 2 most missed problems are averages, mean, and percentages. What they do is they make you do some algebra with the sum. And I'm going to post a whole bunch of average problems probably next Monday or Tuesday. The median means the middle number of the set, but it's only the middle number when it is in order. And the mode is the number that appears the most. You absolutely learned this in middle school. Mean, median, and mode. And they can be handled. They're typically given in a set of rainfall per month or the price of cars or something like that. Or a box full of potatoes was one question off of an SAT many years ago. Lastly, this is the last thing we're going to go over for the day, and that is probability. And probability can be expressed as a percent or a fraction or a decimal. And probability is just the chance of what you want of something happening. So it is the outcome that you expect over the total outcomes. Probability of something happening is just the one event over the total. I'm definitely going to take a bunch of ACT tests, cut out the probability problems, and post them and do a whole 830 prep on it. So here on the last 3 830 preps, last Monday, yesterday, and today, covers everything you need to know to get a good score on the ACT. Let me go over my screenshots. I like the ACT better. Do I like the ACT better? I definitely like the ACT better. I think the ACT is more statistically stable. You get to use a calculator. It's all multiple choice. The SAT has the grid-in questions and a non-calculator section. And as I often say, when will you be without a calculator the rest of your life? So I'm Phil McCaffrey. This was 830 Prep. Thanks for watching. We lasted a half an hour. I did pretty well. I'll see you tomorrow night.